Okay, last week we have discussed about cells, different type of cells, including dry cells and also lead acid cells and other ways of producing electricity. Now, today we are going to do a small experiment that is about these cells and batteries and how we can produce a chemical cell. Right, electric cells and batteries, and how we can produce a cell using this chemical reaction. Actually, so what is happening inside a battery to generate the energy is a reaction, right? So sometimes it can be a thermal reaction, sometimes it can be a reaction due to the chemicals. Anyway, a reaction happens there and that generates electricity. Actually, the electrons. How this is happening? In a dynamo, equipment get generated electricity by rotating or moving. So energy is formatted in, so movement or the rotation is energy again. That energy or is kinetic energy or some other energy which leads to rotating. It can be wind, it can be ocean, it can be wind, it can be water, right? Tidal waves, anything, right? But that can rotate a dynamo, and by rotating and moving, it generates the energy. Solar cell is basically solar energy. That is a thermal reaction. Okay, let's create a battery. So this activity will help you create a battery using copper and zinc sheets. Right here. So we are using two different sheets because one sheet can generate higher number of electrons, whereas the other sheet can acquire those electrons. Actually, this electron path is called electricity. Electrons කියන මේ හැදෙන ඒවා තමයි යන්නේ පුතේ. මේ වයස් දිගේ යන්නේ ඉලෙක්ට්‍රෝන වැඩි තැන ඉඳන් අඩු තැනට මේ ඉලෙක්ට්‍රෝන්ස් ටික යනවා. ඒක තමයි අපි විදුලියක් යනවා කියලා ගන්නෙ. Current එක යනවා කියලා ගන්න. Okay, let me show this. We have done this experiment, I guess, but let's see this in our simulation series. Let me open this PHET website. Right, okay. So you can see here, select different metals and aqueous solutions to build a galvanic or voltaic cell that generate electrical energy. So this is basically, this concept is called galvanic cell, but I don't want this kind of explanation in your grade, but this is for your experimental purpose. Actually, this is done using the lemon, so citric acid inside the lemon. Lime make lime or lemon, you can just there is a citric acid. This is citric acid and this zinc will react, right? Citric acid and zinc will react, that generate some electrons, and that is what using here. Let's discuss this, but before going to this, let's move to the animated supported animation here. Okay, so first thing is, right, experimental set 1, and you can see, so there are two beakers, 500 milliliter beaker here and 500 milliliter beaker here. Left beaker, I would like to put, I will put, okay, for an example, silver. Silver nitrate is one solution. Now, let's use copper nitrate. Okay, copper nitrate. Right. The other side, I'm using zinc. Zinc nitrate, okay. Right. Okay, okay, let's use that silver nitrate. Right here, you can see I'm going to turn on this, and you can see there is a voltage generated, right? Voltage generated, and let's see the things, right? So what will happen in this galvanic cell? This galvanic cell you can see this Na plus. Na plus are in blue color. Nitrate that is in nitrate minus, NO3 minus in this red and blue color. You can see the movement of this. Movement of this minus and pluses. Actually, that is what generate the electricity. You can change the solution, different solutions, and see this. And you can change different solutions, different solutions, and see this. So I will send you this one, and you can use different ones. Let's turn on, and you can see this is not generating. So you see the molecular scale, and you can see again sodium plus and this nitrate is moving, but it's not generating that kind of electricity. So you have to change this zinc nitrate. So let's see, this is plus voltage. Hydrogen electrode, HCl. Right? Hydrogen electrode in HCl. Here copper electrode in copper nitrate. Copper in copper nitrate, and here hydrogen electrode in HCl. But that is not that much effective. Magnesium and copper. Oh, that is very good, right? It's generating plus 2.72 voltage. This is what's happening. So one side magnesium, other side copper. Okay, see the molecule again. You can see again this sodium plus nitrate are moving, but this will generate more voltage is high. So actually, when you see here silver and magnesium, 3 volt. So likewise, you can change the solutions and create this galvanics. Anyway, so let's see this simple lime cell or lime battery, how things happen there. Okay, let's plan accordingly, according to the given example in the book. Lime fruit, right? So this is thoroughly pressed so as not come juice out a plate of copper and plate of zinc and connecting wires. Then musical circuit reading cards of a milliammeter. Okay, so lime fruit thoroughly pressed. Lime fruit thoroughly pressed කියන්නේ මේක හොඳට අර මේ දෙහි ගෙඩිය අතින් මෙහෙම දෙපැත්තට මේවා කරලා හොඳට රබ් කරලා ගන්න ඕන දෙහි ගෙඩිය තැලෙන විදිහට. ඒතු සිට්‍රික් ඇසිඩ් අපි ගන්න බෑ මේක ඇතුලේ තියෙන ඇසිඩ් එක හොඳට ජූස් වෙන්න ගන්න ඕන. හැබැයි මේක ගොඩාක් හද කරන්න එපා. එතකොට දෙහි ගෙඩිය පුපුරලා so what will happen? It will then come out, right? It will actually juice will come out. So don't do that. Without doing that, හොඳට මේක press කරලා roll කරලා ගන්න අත් දෙකෙන් press කරලා ගත්තා නම් ඇති. Plate of copper. තඹ තහඩු කෑල්ලක් ගන්න ඕන. තඹ කම්බියකට වඩා මේකට යෝග්‍ය තඹ කම්බියක් ගන්න පුළුවන්. තඹ කම්බියකුයි galvanized ඇණයකුයි. හරිද? ඇයි මේකට මේ තඹ කම්බියකුයි galvanized ඇණයකුයි ගන්නේ? Okay, why you are taking that? So need to answer. Right? One is copper wire or copper plate, and other one is galvanized nail. Galvanized කරපු ඇණයක්. ඔය දෙක ගන්නත් පුළුවන් මේ වැඩේට. Galvanizing, I explained this in grade 6 class also. Yes, why we are taking galvanized nail? Galvanized කරපු ඇණයක් ගන්නේ ඇයි? Any idea? අහලා තියෙනවද galvanized nail? galvanize කරපු යන අහලා තියෙනවද? ඕවනේ ඔයාලා කතා කරන්නේ නැහැ නේ පුතේ. සනුගේ ඇහෙනවද මාව? සනුගේ?
Yes, sir.
why galvanize nail? galvanize කරපු යනවල මොනවද තියෙන්නේ? යකඩ ඇණයක් අපි ගන්න galvanize nail. galvanize කරනවා කියලා අහලා තියෙනවද? හා?
It is used as the negative part of a battery cell like that.
galvanize nail කියලා කියන්නේ පුතේ මේ ඇන හැබැයි මේ ඇනේ පොඩ්ඩක් නිකන් ඒ ඇනේ පාට ගත්තම මේ ඇනේ චුට්ටක් මේ නිකන් අලු පාට වගේ ඇනයක්. හරිද? මේ තියෙන්නේ normal nail එක normal ඇනයක් galvanize nail එක පොඩ්ඩක් නිකන් අර අලු පාටක් වගේ galvanize nail අපි බලමු was regular nail ඒ පොඩි color වෙනසක් තියෙනවා. හරි? see this. This is common nail, box nail, actually galvanized egg nail. Here. So this is a common nail. So it is, you can see it is brighter. This is galvanized nail. It is like look like ash color. කොහොමද මේ color එක එන්නේ? මේ ash color අලු පාටක් එන්නේ කොහොමද මේ ඇනේට? galvanized nail එකට. Yes. මෙතන තියෙනවා හේතුව. So what is there? Yes. The reason you can see in this image. In galvanized nail මොනවද දාලා තියෙන්නේ galvanized nail වල තියෙන්නේ ආලේප කරලා තියෙන්නේ නැත්නම් ගාලා තියෙන්නේ මොනවද? Zinc. හරි. එතන zinc and copper නේ අපි කොහොමද use කරන්නේ අතන? ඒ හින්දා in galvanized nail there is zinc layer එකක් තිබෙන්නේ. ඇනේ වටේට zinc තියෙනවා. zinc ගාලා තියෙනවා. zinc coated nail එකක්. zinc ආලේප කරලා තියෙනවා. මේක zinc වල ගිල්ලලා තියන්න පුළුවන් නැත්නම් zinc ආලේප කරලා. in galvanized nail zinc is there. ඒක තමයි අපි galvanized nail එකක් මේකට use කරන්නේ. That is the reason, right? I hope you understood. Okay, අනිත් පැත්තට copper wire එකක් හරි සුද්ධ කරපු හොඳ copper තහඩු කෑල්ලක් use කරන්න. Okay, what will happen? Insert the pieces of copper sheet and zinc sheet into the lime fluid. Zinc sheet කෑල්ලයි copper sheet කෑල්ලකුයි මේකට මේව කරන්න ඕන. Connect a wire to each sheet. හැම wire එකකටම wire දෙකටම sheet දෙකක් connect කරන්න ඕන. And then what you need to do, remove the cell of the musical circuit in a musical circuit එක දන්නවනේ අර greeting card වල අර තියෙන මේ card එක open කරනකොට happy birthday to you කියලා වදින card තියෙනවනේ music card. අහලා තියෙනවද?
Yes, sir.
card එක open කරනකොට ඒකේ පොඩි current එකක් ගන්නෙ. ඉතින් ඒක ඇති ඒ යන්තම් වදිනවා බැරන් මේක ටී 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 කියන යන්තම් වදිනවා ඒක. ඒකේ පුංචි current එකක් ගන්න. ඒ හින්දා ඒකක් ගන්න පුළුවන්. ඒකේ cell එක අයින් කරලා remove the cell of the musical circuit in the reading card and connect the free ends of the above mentioned wire to the circuit. You can connect those wires to a milliammeter also. අර ammeter එකකින් මේක මනන්න තරම් current එකක් නෑ. ඒක milliammeter එකකින් මනන්න පුළුවන්. එහෙම නැත්නම් අර වගේ circuit එකකට connect කරන්න. Musical circuit. If you connect this to a musical circuit, you can see, you can hear that it is ringing. It is ringing. It is ringing means generate electricity. එහෙම නැත්නම් right, if you connect the milliammeter, then you can observe the milliammeter is moving. Actually, we are using center zero milliammeter or center zero galvanometer. The reason is, so when we swap the edges, make a zinc තහඩුවයි copper එකයි මාරු කරලා බලන්න පුළුවන් අපිට. When you swap the edges, the millimeter shows one direction. When you swap the when you swap it back, it shows the other direction. එතකොට මේකේ millimeter එකේ මැද බිඳුව එක ගත්තම දෙපැත්තටම පෙන්නනවා. ධාරාවක් එක ධන පැත්තට zinc ඉඳන් copper වලට ධාරාවක් ගියත් copper වල ඉඳන් zinc වලට ධාරාවක් ගියත් ඒක පෙන්නනවා. So that is why you have to take the center zero millimeter, because you can measure it easily. Okay, so this is called lime battery. We have, I think we got some exposure to a lime battery. Tinkercad වලින් අපි ඔක කරා. We did that using Tinkercad, right? Can you remember? Yes or no?
Yes, sir.
Right. If not, tell me, then I can do it again and show. Okay, construct of a simple cell. Okay, now galvanic cell, the other one. So small beaker, 250 milliliter beaker එකක් ගන්න පුළුවන්. And copper and zinc sheets. මේ ගොඩක් වෙලාවට copper zinc යොදා ගන්න. ඉතින් අතන තිබ්බ අපිට තව powerful එකක් අපි හදාගත්තනේ. එහෙම use කරගන්න පුළුවන්. හැබැයි අර ගොඩක් ගන්න නෑ පුතේ. මේ වගේ ගණන් අරවන්න ඒවා. ඒවා හින්දා ගත්තම දැන් මේක අපි ගත්ත එකක් මොකද්ද? මේකනේ. ඔව්. තමයි silver and magnesium. පොඩ magnesium silver දෙක චුට්ටක් ගණන්. That is why, and silver nitrate, magnesium nitrate, basically, so this is a bit expensive to create this cell. That is why we are using the easier zinc one and this copper one, right? Okay. But you can treat this one also, silver magnesium too. Okay, let's go to that. Here, a torch bulb and bulb holder, then small motor, iron, or nichrome wire, nickel chromium wire, which is about 30 centimeter long. Center 0 ammeter again. And sulfuric acid, dilute sulfuric acid. This is basically battery acid. තනුක sulfuric කියන්නේ මේ වෙනුවට වට ගන්න පුළුවන් battery cells වලට පුරවන ඔය කඩවල වල තියෙන hard drive වල තියෙන. Battery cells වලට පුරවන එකක් තියෙන එකට battery acid කියලා කියන්නේ. ඒක ගත්තනම් හරි. Right. Clean the copper and zinc sheets thoroughly and connect the piece of wire to end of each sheet. Right. එතකොට copper පැත්තේ zinc පැත්තේ ආපහු wire දෙක connect කරනවා. Fill half of the beaker with diluted acid. Dilute acid. What is that? Sulfuric acid. Sulfuric acid මැදට දා ගන්නවා. Dip the copper and zinc sheet into the acid without letting them come into the contact. එකිනෙක ගෑවෙන්න තියන්නේ නැහැ පුතේ. වෙන වෙනම මේ දෙක අර බීකරේට බස්සන්න ඕන. Connect the torch bulb and see. එකක් තමයි torch bulb එක connect කරලා අපිට බලන්න පුළුවන් whether there is a current. So you can see this is copper, this is zinc, and then you can connect the bulb and see whether that generates electricity. The second thing is you can test that same with the motor. Right? Actually, you can see, so you have to take small motor, don't take a large one. The motor will slowly rotate. You can observe. Motor එක හිමීට කැරකෙනවා වලට පේනවා. ඒ වගේම මෙතනත් bulb එක දැන් මේ torch bulb එකට current එක අඩුවෙන් ගන්න. ඒකයි torch bulb LED එක මේක පොඩ්ඩක් අමාරුයි. එහෙනම් torch bulb එකක් ගන්න ඒක observe කරන්න ලේසි. Right, torch bulb, it's easy to observe. Right, then by doing that, you can observe that there is an electricity generator. Right, observation in the bulb bulb is connected, observation in motor is connected, and you can measure this, right? Observation with the coil is connected, ammeter is connected, and any other observation. You can connect the coil. Coil එක connect කරන ප්‍රත් වෙනවා nichrome එක. And nichrome coil if you connect, because of the electricity is getting heat. And here bulb is connected, you can see a very small light, and the motor will slowly rotate. So these observations, but so sometimes you will not see the bulb as well as the motor rotation. You are doing this, Sanugi. You have the motor, but batteries, right? You can share the screen, Sanugi. You can share the screen if you have. Not screen. You can share the camera, please, Sanugi. Yes, I think you are interested in doing practicals. Very good. Sanugi. Oh. Sorry? Okay, Sanugi, what you can do is, since you have materials with you, Sanugi, you can start, shall I spotlight it? Okay. You have the motor, right? So what's this? It's not clear. It's a bulb. Yeah, it's a bulb. Okay, it's a bulb. What else you have? A motor. Okay, good. Do you have sulfuric? Dilute sulfuric? No. No. So you have the battery and all this. Battery pack, right? Okay. So if you're interested, Sanugi, what you can do is, you can start doing recording videos and doing small YouTube channel. That I suggested to most of my kids, and they are doing it now. We have physical classes in STEAM now. STEAM එකේ ගොඩාක් ළමයි science practicals කරනවා. STEAM එකේ මම ඔයාලට පෙන්නන්නම් මේක කියලා මට අදහසක් ගන්න. So this is one practical done by our kids. So this is very common one. You have seen this before also. idea එකක් ගන්න. අපේ කට්ටිය කරනවා. ඉතින් ඒගොල්ලන්ට මම කියලා තියෙන channels කරන්න කියලා. This is acid base reaction. You can see this is steam lab. Steam lab එකේ දැන් මේ ඇතුලේ the steam lab එක දැන් ඔයාලට access නැහැනේ පුතේ. ඔයාලට මට දෙන්න තිබ්බනම් හොඳයි. එකම දේ අපේ centers දෙකයි දැනට තියෙන්නේ. One is the center in Veyangoda, the other center is it's going to open in Gampaha. And next center will be in Kalutara and next center will be in Goan. Then if you are nearby, you can come to those centers too. So anyway, we will be opening these centers in actually, so our plan is to open 10 centers. සමහර විට ඔයගොල්ලෝ in ප්‍රදේශ ආවුනොත් ඔයාලට ඇවිල්ලා experiments කරන්න පුළුවන්. Actually, the idea is come do experiments and learn. Right? ඔයාලට තියෙන ඇවිල්ලා experiment කර කර ඉගෙන ගන්න මේක හදන්නේ අපි. And මේ labs හදන්නේ, steam labs හදන්නේ, not just for the chemistry, not just for the science, it's for IT, robotics, all these things. So you can come and do the practicals. So if you are nearby, you can come. Sanugi, may I know your location, Sanugi? Sanugi ke location එක කොහෙද Sanugi? Sorry? I can.
nearby Kalutara.
Kalutara one, then you can. Kalutara is third center that we are going to. After Gampa center, we will be moving to Kalutara. Sanoli? Where's Sanoli? I can.
Veyangoda.
Sanoli දෙන්න පුළුවන්. Sanoli එනවද අපේ? Steam lab එනවද?
No, sir.
Sanoli school එක මොකද්ද?
Veyangoda Central College.
Central. Sanoli, you can come to the Steam labs. It's in Veyangoda. Still, we have not visited. අපේ ඔයගොල්ලන්ගේ school එක visit කරනවා පුතේ. අපි ඔයගොල්ලන්ගේ school එක visit කරනවා කියන්නේ අපිට principal sir එකක් මේ කතා කරලා තියෙන්නේ. තාම අපිට මේ date එකක් දුන්නේ නැහැ. නැත්නම් අපි school එකට ඇවිල්ලා කියනවා. Anyway, you can come to the place, right? This is really nearby. All 7 days it is open. You can come and do the practicals. Come on, take that advantage. එක ගන්න මේ ඔක්කොම වලට ටික තියෙනවා ඇවිල්ලා කරන්න ඔයාලට. තිස්සන්දි? තිස්සන්දි?
From Bandara.
Bandara, yes. අපි අන්තිමටම තමයි ඔය පැත්තට එන්නේ බදුල්ල. බදුල්ල බණ්ඩාරට ටිකක් කාලේ යනවා ඉතින් ඔයාට. Side, what's your location, Side? Side, not the. Hello. Side is not there. Okay, anyway. Right. Is from. Yes. What is your location? What is your hometown, Side? Yes. So the Colombo, right? We are coming to Colombo. Our maybe third or fourth will be Colombo. So that's easy. You can access them. But anyway, so those who are in like okay, Sanoli, if you are in Veyangoda Sanoli, that's the easiest way is. So I'll tell you the address. I'll share you the address. So that is number 10, Baduragoda Road, Veyangoda. So that is nearby the Veyangoda Dam Road. Right? So this is very important to you. So try to come to the center and do your practicals. So you can do electronics and chemical related practicals, microorganism related practicals, a lot. Right? You can come there. Okay, Bhuti. So now you have a clear idea on that. No? So physical classes, you can do these experiments. Right. Actually, the online classes we can do. අපේ තියෙන plan එකක් දැන් ඔය centers හැදුවට පස්සේ kids ඔයාලට එවන්න. We will send all the materials to you. But it will be a bit expensive because one by one we need to send? No, that will be a bit expensive, right? Okay, so I'll give this. So please try to use this and get exposure. There is another cell. This is actually a video based one. This is again electrochemical cell. One side zinc, other side copper. Let's watch the video. This is YouTube one. But let's watch it.
Hey, PCCL channel greets you. When chemical energy is converted into electrical energy. Here, by placing a voltmeter with the COM terminal on the zinc, it displays a positive voltage of 1.1 volts. This is a redox reaction. 1.1 volts is the standard potential. There are as many electrons captured as electrons supplied. So this is an electrochemical cell. I found a tiny engine in a model shop and managed to get it running with this assembly.
So you can see here. So this is copper sulfate solution, as we said. Copper sulfate solution. And this side you can see the zinc, and the other side you can see the copper. And you can run small motor using this. So as he said, it is 1.2 volt, but you can try. So depends on the copper and the copper and the zinc place that you are using and the concentration of the copper sulfate solution. It depends. Actually, this one we are using. Are we using copper sulfate, or I think we are using sulfuric, right? But sulfuric can be used to generate this sulfate, right? That is possible. Here, yes, we are using sulfuric. Here, dilute sulfuric acid. That is also okay. Copper sulfate is also okay. You can use one of these. But easy to find is sulfuric acid, right? Or copper sulfate with nil part. Okay, this need to be done, right? So who can make a video? How the video Sanogi? Sanoli, who's going to make video? You can do? Can you? Sanogi, can you? All right, okay. Do it and share with us. Okay, do it and share with us. Then everyone can look at that. You can share using your YouTube channel also, then you will get some views also. YouTube channel share. Okay. Center zero ammeter, I said this. Center zero ammeter make a samalata center zero galvanometer kilak. Ammeter center zero galvanometer. So the idea is basically because we don't know the direction of current initially. Direction of current the anode, the cathode. We will recognize where's the anode, where's the cathode. That is true. Anode එක කොයි පැත්තටද යන්නේ, cathode එක කොයි පැත්තටද යන්නේ කියලා ඒක ඇත්ත. හැබැයි එහෙම දැනගන්න කලින් අපි ධාරාවේ දිශාව බලා ගන්න ඕන නම් අපි center zero ammeter එකක් use කරනවා. Right? Or center zero galvanometer, we can use that. When you are using the center zero ammeter or galvanometer, let's see this. Okay, center zero galvanometer is this. Right, galvanometer is basically universal. Can you see the animation? Oh, this is no, this is not for the animation purpose. Another one is center zero milliammeter. Because the direction of the current, so we don't know. Koi dishaවට අපිට current එක යන්නේ කියලා initially අපි දන්නේ නැහැ. ඒතර අපිට zinc copper මාරු වෙලා අපි තියන්න පුළුවන්. ඒක කාලයක් ගියාම අපිට තේරෙනවා zinc පැත්තෙන් නම් copper පැත්තට තමයි electrons යන්නේ. හරි මෙතන නම් තියෙන්නේ voltmeter එකකුයි ammeter එකකුයි අපේ DC construction kit එකේ බලමු. Okay, here also this is also interactive one. I will share the link of this to you. Right, make a link එක මම share කරන්නම්. Everyone can test that. Try to use copper electrode one side. Right, other side try to use zinc. The solution is basically you can use salt bridge and the solution, let's put copper තියනවාද මේක nitric acid තියෙනවා acid මොනවාද තියෙන්නේ ආයි හරි අපි copper එකට copper nitrate ම දාමු මේ පැත්තට දාමු zinc වලට zinc nitrate. Right, okay. Then let's connect this. Oh, can't we connect this? No. Measure cell voltage. Here, it's automatically connected. Actually, zinc is connected to plus, copper is connected. This is minus. So this is multimeter. Make a digital multimeter. This is a digital multimeter. You have to measure the cell voltage. It is minus, right? Because the me pattern ni apita make patta maru karanna puluwan. Can we change the side? Because zinc is working as the negative one. Either zinc pattern tama rine එක connect karanna ඕන, ධන එක copper පැත්තට connect කරන්න ඕනේ. තමයි හරි ක්‍රමය. අපි පැත්ත මේකේ මාරු කරමු, right? We are going to use zinc here. එතකොට solution එක මම දානවා zinc nitrate. Zinc nitrate. Nitric acid දැම්මත් කමන්නේ zinc nitrate හැදෙනවා. Right, මේ පැත්තට දාන්න copper, දෙපැත්තටම zinc දාලා වැඩක් නැහැ. The other side you need to put copper and then copper sulfate, right? So copper nitrate. Okay, now you can measure the cell voltage. It is 1.1 volt. So this can rotate a motor. 1.1 volt කියන්නේ motor එකක් කරව ගන්න පුළුවන්. LED එකක් පත්තු කරන්න බෑ. අපේ torch bulb එකක් පත්තු කරන්න පුළුවන්. So this is in the middle. This one is called salt bridge. මේකේ තියෙන්නේ sodium chloride. මේ මැද්දේ තියෙන්නේ salt bridge. එකේ තියෙන්නේ දැන් මේකේ නම් දාලා තියෙන්නේ sodium nitrate. My nitrate මන ඉතන අරන් තියෙන්නේ. Then you can put sodium nitrate or salt bridge. මේ මැද්දේ U නලයක් දාලා එතන control කරලා තියෙනවා. ඒකට sodium nitrate දාලා. If you are using, this is called electrochemical cell. Right, මේක අර අපි හදපු එක නෙවෙයි. මේ වගේ වෙනසක් තියෙනවා. So actually previous one we have used only one no. එක solution එකයි use කරේ. මේ දෙකම අපි මේ දෙක ඉගෙන ගත්ත දෙකේම මේකෙත් salt bridge එකක් තියෙනවා. So using the salt bridge this is connected. But the one that we have tested අපි test කරපු එකේ තියෙන කොට එක බීකරයයි. ඒක මේ එකකවත් නැහැ. අපි බලමු copper sulfate තියෙන single copper sulfate. අපි බලමු image එකක් තියෙනවද කියලා. මේ animation වල මොකක්වත් නැහැ මම බැලුවා ඒක. Copper zinc cell. ඒ තියෙන්නේ අරකම තමයි. With the salt bridge, without salt bridge. Salt bridge එක නැතුව අපි බලන්න ඕනේ. Let's use without that sulfuric acid. Yes, it's this one. Okay. Right. Here dilute sulfuric acid. Don't use the sulfuric acid 1M or some because it will surely vanish this one electrode. ටක් ගාලා react කරනවා. හින්දා තනුක sulfuric ගන්න. නැත්නම් sulfuric ගොඩක් සැරයි. acid එක හින්දා තනුක sulfuric ම පාවිච්චි කරන්න. Zinc and copper, you can see this is working as a minus and this is working as a plus. So actually what will happen? So you can see this is the reaction. But this you will learn in the future grades. එතකොට zinc කියන එක sulfuric එක්ක ප්‍රතික්‍රියා කළා මේ පැත්තෙන් hydrogen යනවා. ඔයාලට පේනවා මේක බෝල යනවා. ඔයාලා hydrogen balloon හදලා තියෙනවද? Have you made hydrogen balloons? Sanuli, yes?
Yes, sir.
මොනාගෙන් හදලා තියෙන Sanuli? Hydrogen balloons. කොහොමද හැදුවේ? How did you made hydrogen balloons? Yes?
සර් කයරකින් පුම්බන්නේ ඒකෙන් වෙන කරන් තමයි පාවෙන්නේ නැතුව පාවෙන්නේ.
මොකේද පුතේ? ඒක nitrogen.
කාර් එකේ රෝද
නෑ ඒකෙන් බෑ. ඒ nitrogen hydrogen මම අහන්නේ hydrogen H2 balloons. Hydrogen balloons හදුවා H2. හරි ඔයාලට කරන්න පුළුවන් අපේ ස්ටීම් එකේ ප්‍රැක්ටිකල් එක මම දාලා තියෙනවා. එහෙම නැත්නම් ඔයාලට කරන්න පුළුවන් one easy method is you can use aluminium foil අර කඩවල තියෙන aluminium foil. aluminium අර කෑම ඔතන්න ගන්න ඒවා තියෙන්නේ. aluminium paper ඒවා papers වගේ තියෙනවා කඩවල මේ aluminium foil එක. මේක ඉස්සර නම් chocolate කොළ වලක් තිබ්බ දැන් නම් අඩුයි. දැන් මොනියම් plastic වගේ ගන්න තියෙන්නේ. You can take this aluminium foil and then use sodium hydroxide. We call caustic soda. So sodium hydroxide මේවත් කඩවල hardware වල තියෙනවා. So caustic soda කියන්නේ මේකක් හරිද? ඒක භස්මයක්. It's not a acid, it is a base. Right? But caustic soda with aluminium will AL reaction. So this is what happened. So NaOH plus aluminium, the reaction will create H2O. With the H2O, it will create sodium aluminate and hydrogen. මෙහෙම හදන්න පුළුවන් hydrogen balloon. Aluminium වලට sodium hydroxide උයි වතුරයි දැම්මම නිකම්ම ප්‍රතික්‍රියා කරන්නේ sodium hydroxide වතුරයි දෙකම දාන්න. Sodium hydroxide and water with aluminium will react and produce sodium aluminate plus H2. H2 is basically hydrogen. Make a ක්‍රමයක්. Another method is sulfuric and zinc reaction. Sulfuric and zinc reaction. Sulfuric and zinc reaction here, zinc and H2SO4 will create zinc sulfate and hydrogen. මෙතනදී zinc ඔයාලට හොයාගන්න පුළුවන් බැටරි වල පොත්තේ. බැටරි තියෙන්නේ dry cell එකක් කැපුවම තියෙන zinc තහඩුවක් වටේට. එතන පරණ ඒවා ගන්න, පරණ බැටරි ගන්න, අලුත් ඒවා ගන්න එපා. බැටරි බහැපු බැටරි තියෙන්නේ. බහැපු පරණ බැටරි වල වටේට තියෙන zinc තහඩුව. There is a zinc cover. And all these dry cells, the outer ආයක පොතේ දීලා තිබ්බනේ පුතේ. Dry cell වල outer layer එක zinc මොන්ද කාමේ තියෙන. Dry cell, this outer layer, this one is basically zinc. Right. Outer layer is zinc. Not the cover. Cover එක නෙමෙයි, cover එකට ඇතුලෙන් තියෙන. You can use that zinc and then battery acid. ඔය දෙක දැම්මම ඔය දෙක react කරලා zinc sulfate හැදෙනවා. Zinc sulfate and H2. And එකයි මම කියන්නේ මේකට මේ අපි ගන්නව හොඳ නැහැ මේ සාන්ද්‍ර sulfuric. Should not take high concentrate sulfuric. The reason is when you are using high concentrate sulfuric, what will happen? So it will react so fast and zinc electrode will be soon vanish. Make a දිය වෙලා යනවා zinc electrode. එහෙම නැත්නම් මේක ටිකක් හෙමින් දිය වෙන්නේ මේ වැඩේ වුණා. Actually what will happen, this hydrogen plus will be produced and zinc. Here you can see zinc and sulfuric, zinc sulfate. මේ දෙක එකතු වෙලා zinc sulfate හැදෙනවා. And these electrons, making galvanic electrons, will travel from here to here. Electrons galvanic මෙතනට යනවා. හරි එතකොට copper පැත්තෙන් මොකද්ද වෙන්නේ? Right, you can see copper will take these electrons and also these pluses from hydrogen, and here so it will produce hydrogen bubbles. end එකේ පැත්තෙන් hydrogen වායුව යන්න පටන් ගන්නවා. Actually මේක තමයි දිය වෙන්නේ. zinc මේක දිය වෙලා යනවා. ඒකලා hydrogen මේකෙන් හැදෙනවා. So that is what happens. And the solution will be zinc sulfate. Solution එක zinc sulfate තමයි මේකේ අන්තිමට හැදෙන්නේ. So this you can do as an experiment, but this procedure will soon destroy our cathodes. Zinc. එතකොට මේක කරලා බලන්න ලේසි එකක්. බැටරි ඇසිඩ් ගන්න, සිංක් තහඩුවක් ගන්න, බැටරි එකේ කවරේ තියෙන කොපර් තහඩුවක් ගන්න ඔයාලට පුළුවන් කොපර් තහඩුවක් තියෙනවා, සම්බ තහඩුවක්. නැත්තම් ඉතින් තව කම්බියක් අරගෙන පොඩක් තලලා ගන්න. හොඳට බලන්න ඕන. මොන ගන්න that will also go. Okay. Otherwise you have to use a bridged one. මේක ටිකක් අමාරුයි salt bridge එකක් මැද්දෙන් දාලා zinc sulfate, copper sulfate දාලා copper sulfate පැත්තට copper, zinc sulfate පැත්තට zinc උත් දාලා අපිට පුළුවන් ආයත electrons generate කරගන්න because of this oxidization and the reduction. So that will also generate a current. This is the second method, but this will be bit hard. And this is bit hard as you need 2 beakers to do this. Okay, do these experiments. You have both in your arm. This is the simple cell like a TNA, right? So that experiment you can do, and this is how you can connect few simple cells. Actually, if you connect a bulb or motor to this, you can see it will rotate so fast because the voltage generated is now higher than the previous. So this is called serial connection of the batteries. හරි මේ වගේ අපි දෙක තුනක් use කරොත් එතකොට අපි හිතමු මේකේ තියෙන 1.1 volt කියලා. Assume that there is 1.1 volt here. Then here 1.1 volt and here also 1.1 volt. And here also 1.1 volt means this can light up LED bulb easily because it will totally generate closer to 3.3 volt. So this can light up LED battery and this can rotate a bulb, rotate a motor too. That is using the multiple cell connection method. So I would like to invite you to try this, the previous method. This so please go through the video again. Video එක බලන්න. What you need: the battery acid, copper, and zinc. That's it. It's very easy. Okay. So and similar to this setup, you can reconnect multiple batteries and connect. So here 4 dry cells connect in wire and piece of a cardboard, sellotape, and the rubber band. Why? Because connect dry cells as shown, sellotape or rubber band can be used to connect wires, dry cells, and wrap the dry cells around the piece of cardboard and make it hardly packed. This is called a battery pack. And this battery pack, what is the voltage? So okay, if I say one battery will have 1.5 volt, can you tell me the voltage of the battery pack? If one battery got 1.5 volt, what is the voltage of this battery pack? Yes. What is the voltage of this battery pack? One battery 1.5 volt. What is the total voltage of this battery pack? මේකේ මුළු voltage එක කොච්චරද? කීයද? Four batteries are there. There are 4 batteries. Okay, let's connect. So you can do this using our simulating software. I'm making current
7 volts.
7 in the band.
No.
7 or 6?
5 volt.
5 volts.
6.
It is 6, right? It is clearly 6. So there are 4 batteries. Okay, connect and see. Take a battery, change the voltage to 1.5. Change the voltage to 1.5 like this. Copy and paste. Oh, sorry. Oh, if you cannot copy and paste, take a new battery. Change the voltage to again 1.5. Take a new battery. Change the voltage to 1.5. And take a new battery. It is not 5.5, it's wrong. You have to add them up. Just do this practically. Practically, change another battery. There are 4 batteries. Change the voltage to 1.5. Then what you need to do is rotate the battery other way. So here you can rotate the battery like this. Then connect minus and plus like this. And this minus and plus like this. This minus and plus like this. Now take a wire, take another wire. You can use voltmeter and measure the voltage. So each battery 1.5, 1.5, 1.5, 1.6 or 1.5. You can see it is 6 volt. It is 6 volt. Understood? Hello?
Yes, sir.
Please do this, right? Please do this. Experiment on this. I already said you. So please experiment on this using this link. So that will generate 6 volt totally, because you are connecting batteries in serial mode. But if you try to connect batteries in the parallel mode, so what will be the voltage? If I connect batteries in the parallel mode can all pluses I'm going to connect and all minuses I'm going to connect. Let me rotate the battery again, rotate this again too. Then I'm connecting all pluses like this, here plus plus, this one also plus plus, this one also plus plus. And I'm connecting these minuses also. Then what will be the voltage? Yes, then what? Here I have to take one from plus then. What will be the voltage? Yes? Come on, guys. Thank you, the voltage. Okay, now it is only 1.5, right? The hatarak connect karat, if I connect them parallelly, it is only 1.5. So remember this rule. If you connect battery parallelly, the voltage won't change. But if you change battery serially, the voltage will be added. So put a stick and write down somewhere in the book maybe. Serial connection of, put a stick and write down, batteries will add voltages of all the batteries. Parallel connections of batteries will not add. This you need to remember. Serial will add, parallel will not add. Okay, with that I will stop for today. Let's discuss the remaining part in next week. So good night. See you all next week.
Good night, sir.
Good night, sir. Thank you, sir.